Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved question number 2 related with exercise number 5.1 related with chapter number 5 integration class 12 mathematics. Question number 2 was related with the evaluation of different type of indefinite integral by the method of substitution. In today's video, I am going to solve the same question but related with the same topic. Evaluate the following indefinite integral by the method of substitution. But the question is question number 3, which is the next question of the same exercise number 5.1. So let's move toward question number 3 of chapter number 5 integration exercise 5.1 class FSC part 2 mathematics. It tells that evaluate the following indefinite integral by the method of substitution. There are total 4 parts in this question. Part number 8 tells that evaluate integral of 6 e power 60 dt. So over here I can write the integral in the form of first let's suppose I write e power 60 e power 6 t, and after this I write this 6 dt. And now after this look over here, and the e power is 60. So let's suppose if we take 60 is equal to some variable, so the derivative of 60 is available on the right hand side. It means that over here we will substitute this 60 is equal to, let's suppose I take a variable z. So over here we have the differential operator dt, so it means that we will differentiate both sides with respect to dt. To dz by dt will be derivative of 60 with respect to t is 6. So now shift dt on the right hand side, it becomes dz will be equal to 6 dt. Now putting these two values, so our new integral will generate. So integral of e power 60 we suppose is we can write it e power 60 we suppose actually z, so it become e power z dot 6 dt is actually equal to dz. Now remember that integral of e power x dx is always equal to e power x. So over here the variable is z and the differential operator is dz. So the answer will be same, but over here the variable is z, so we will just replace x with a z. So the answer will be e power z plus constant of integration. Now recall that our original variable was t not z. So again replace the value of z is equal to 60 over here. So it become e power z is 60. So it become e power 60 plus constant of integration. So this is actually the required and desired answer. Now move to the next part of part number B related with question number 3. It tells that integral of x into exponential e power pi x square plus 1 dx. Integrate this indefinite integral by the method of substitution. So let's suppose if I suppose this pi x square plus 1 is equal to some variable, so the derivative will be 10x plus 0. So over here x is present but we don't have 10. So how can we make this x 10? So we will just rationalize it. So it become integral of multiply 10 and divide with 10. So 10 by 10 again gives us 1 into x. And over here this will comes down as it is e power 5x square plus 1 into dx. So now over here this 1 over 10 we can write it outside of the integral, and inside the integral we left with 10x into exponential pi x square plus 1 into dx. Now over here let's suppose I take this pi x square plus 1, 5x square plus 1, let's suppose it is equal to variable w. Differentiate both sides with respect to x. So because over here the differential operator is dx, so we will differentiate both sides with respect to x. So it become dw by dx will be derivative of 5x square is 10x and derivative of 1 is 0 because this is a constant. Now after this it become dw will be equal to 10x into dx. Now putting these values, so our new integral will generate in term of variable dw. So 1 over 10 integral of 10x into dx. 10x into dx, this is actually dw. And e power pi x square plus 1 we suppose w. So it is very easy now. You know that e power x dx integral is always equal to e power x, so e power w with dw integration will be e power w and plus constant of integration. Now replace the w with the original variable 5x square plus 1. So it become e power 5x square plus 1 and divide with 10 and plus constant of integration. So this is actually the required and desired answer. Now move to the next part of part number C related with the same question. Number 3 tells that integral of x square minus 2 into e power x power 3 minus 6x plus 4 into dx. Solve this indefinite integral by method of substitution. So let's suppose if I take this function x cube minus 6x plus 4 is equal to some variable. Let's suppose I take it equal to a variable v. Now differentiate both sides with respect to x, so it becomes dv by dx. X cube derivative is 3x square minus 6x derivative is minus 6. 4 is the constant, its derivative is 0. So shift dx on the right hand side and take 3 common from over here. So by taking 3 common, we left with x square minus 2 and shift dx on the right hand side, it becomes dx. Now over here we need x, we need with x square minus 2 into dx. So divide both sides with 3, so it becomes dv by 3 into is equal to x square minus 2 into dx. So our new integral will generate e power x cube minus 6x plus 4 x square minus 2 into dx. So e power x cube minus 6x plus 4 we suppose v, so it becomes e power v. X square minus 2 into dx is dv by 3. Now take 1 over 3 common, we left with e power t dv integral. So integral of e power a is e power v and plus constant of integration. Now again replace this v with x cube minus 6x plus 4. So this is actually the required and desired answer. Now move to the last part of today's lecture and the last part of question number 3, part number D. Integral of 8 power 7 minus 3x square into minus 6x into dx. So over here this function derivative is present over here. So it means that we will take 7 minus 3x square is equal to a variable, let's suppose v. Differentiate both sides with respect to x, so it becomes dv by dx will be derivative of 7 is 0 because this is a constant. Derivative of minus 3x square is minus 6x. So shift dx on the right hand side, it becomes dv is equal to minus 6x into dx. Now putting this value and this value in the given integral, so the new integral will generate. So integral of 8 power 7 minus 3x square is actually equal to v. So it becomes 8 power v into minus 6x dx is actually dv. So put dv. So integral of 8 power v dv will be, remember a formula that integral of a power x dx is always equal to a power x divided by ln of a and plus constant of integration. Using this formula we will get the required result. Over here we have a power x and over here 8 power v. So on the right hand side we have a power x, this value. So the same value will come in the result 8 power v and just divide with ln of a. A is actually a constant, so constant is 8, so it becomes ln of 8 and plus constant of integration. So over here this is not the required result because over here the variable is v and the given question we have variable x. So replace this v with 7 minus 3x square, so it becomes 8 power 7 minus 3x square and divide with ln of 8 and plus constant of integration. So this is actually the required and desired answer. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about second year mathematics. Thank you.